All right, one more problem from out of section 2.3 I want to take a look at with you is number 34. This is a problem where we want the equation of the tangent line to this curve at a equals 2. This should be way easier to do now than it was last week when all we had to work with was the definition of the derivative. Now we know some derivative rules. The process of taking a derivative is much more efficient for us now. So if we want to know the equation of the tangent line to this function at the x value of 2, what we're going to need to know is we're going to need to know the slope of that tangent line, and the slope of the tangent line evaluated at x equals 2 is going to correspond to whatever our derivative is at 2, because derivatives still give slopes of tangent lines. So we should be able to take the derivative of this, toss 2 into it, and use that as the slope of our tangent line. So if I start by finding f prime of x, I'm just going to use the power rule for derivatives to take the derivative of this. So I'm going to multiply this coefficient by that exponent, get a 2, subtract 1 from that exponent, get a 1. If I multiply this coefficient by that exponent, I'd get a negative 2. If I subtract 1 from that exponent, I'd get a 0. If I put an x to the 0 here, I can simplify it to be a 1 and it's just gone. So I just get negative 2 for the derivative of this middle piece. Derivative of a constant is 0. So our derivative is this. If we want the slope of the tangent line at 2, all we need to do is evaluate this derivative at 2, and the slope of our tangent line ends up being 4 minus 2, or just 2. So here is our slope. What happens a lot when we're doing this sort of problem is people have done all the calculus and they quit here. But we want an equation of the tangent line. All we have is the slope of the line. If you want an equation of the line, you're going to want an answer either in point slope form or slope intercept form. To find the equation of the line, I not only need its slope, but I also need to know a point on the line. I know that my line is going to hit this curve at the point of tangency. So the point of tangency has an x coordinate of 2 and a y coordinate of f of 2. And if you compute f of 2, let's see, if we put a 2 there and we square it, and we put a 2 here and we multiply it by negative 2, and then we add 1, well, 2 squared is 4, minus 2 times 2, so back to 0, plus 1. I guess all I need to do to finish this up is I need to find the equation of a line with slope 2 through this point, and I'm done. So it just finishes as an Algebra 1 problem, but you definitely want to make sure you finish it. So I'm going to go to slope-intercept form. I'm going to take my y value on the line, which is a 1, put it in place of y. I know my slope is 2. I know my x value on the line is 2, and that x value corresponds to this y value, plus b. So I'm looking at a 4 there. If I subtract that from each side, I'm looking at negative 3 for my b value. So what would the equation of my line be? Well, y is equal to the slope that we found times x plus b, which we found to be negative 3. So there's the equation of your tangent line. This should be a much easier type of problem to do now than it was last week when all we had to use was the definition of the derivative.